How will we address the climate crisis? Climate One with Greg Dalton brings together advocates, influencers, and policymakers in empowering conversations that connect all aspects of the climate emergency, the individual and the systemic, the scary and the exciting, to help you understand the most critical issue of our time. Because addressing the climate crisis begins by talking about it.
Batteries are a critical part of the transition away from fossil fuels. From electric vehicles to grid-scale storage for wind and solar, demand for batteries is expected to grow 500% by 2030. In order to meet that demand, we're going to need a lot more of them. J.B. Straubel co-founded Tesla and spent 15 years as its chief technology officer. Now he's CEO of Redwood Materials, a company dedicated to making new battery components, largely by recycling old ones. How do we build a battery supply chain that meets demand while reducing the need for new mining? Today on Climate One.
As an undergraduate at Stanford, you kind of learned about climate. I think you've always been interested in those things, but what prompted you to dedicate your life to focusing on climate solutions?
Well, for me, it was probably a passion for the technology and the engineering first. That's kind of what drew me into climate and sustainability. I had a lot of friends in college that were hardcore environmentalists and even activists, and I didn't totally understand where they were coming from initially, but I think I've kind of migrated to really see that side of things. And initially, for me, it was just a love for the technology and feeling like it was the right way to engineer systems, where you didn't have sort of some open-ended waste or some constrained material that would eventually run out. It was very elegant.
Right, so there's many different pathways people come through: technology or a connection to the earth or perhaps economics opportunity. So how have you come to realize your environmental friends, like the urgency that they're feeling or they're conveying?
Well, I think it's a combination of watching some of the effects of the basically the cumulative effects of what we're doing, seeing the trajectory and how difficult it is to actually change some of these industrial systems. To me, that really resonates, and it sort of brings a sense of urgency to this whole problem, which is we can't just sort of wake up one day and flip a switch and decide, oh, okay, yeah, we really should stop burning fossil fuels. Let's do that today. It's a very pervasive, very challenging problem, and touches so many parts of our lives that we need to prepare and really engineer toward a solution way, way ahead of time.
Right. Without that scientific or urgency, business will go at the rate that's comfortable for business, which is not fast enough. Tesla's first production model, the Roadster, used about 6,800 batteries, essentially laptop batteries strung together.
6831, actually.
6831, yes. My producer wrote that, and I rounded it up, but that's 6831.
Still remember that number.
And looking back now, how crazy does that sound?
I mean, it in hindsight, it was...
or genius, maybe.
I don't know about genius. Many people said it was nuts at the time. These were laptop batteries, basically, way back then. They were, slightly tuned and improved laptop batteries, but stringing together thousands of those at the time when, laptops were catching fire in airports and causing other problems, many people were skeptical, and they had some data to be skeptical. But in the end, it turned out to be a really quite robust solution. And as far as I know, there's never been a Roadster fire in the entire history of that small fleet of cars, anyway.
Right, and there's kind of an interesting narrative of how people talked about the company, particularly people in the industry. So tell us about how the auto incumbents, the giants, kind of shifted their narrative of Tesla from the Roadster days to today.
It was fascinating to watch. It was kind of the innovator's dilemma played out, in live feed. But in the beginning, as you said, we were completely dismissed, almost mocked if there was any opinion whatsoever. The Roadster was impractical, it was unsafe, it would never work. I was amazed at how many people thought we were outright lying about we'd say, okay, it's going to go 200 and, some miles, 250 miles, and they'd say, that's a lie. I'm like, well, no, it's not. We've engineered it. It's going to do it. We'll build it and show it. But that was interesting in the very beginning. It was kind of mockery, dismissal, and that evolved over time. But there was always this sense of
Then came the Model S, and you were like like a rich boy's plaything.
Yep. I mean, that suddenly the Model S, was 10 times the volume or more. It won Motor Trend Car of the Year. It was this impeccable safety record, had obvious data really supporting it, but still there were a lot of reasons why that couldn't change the industry. It doesn't have enough range, or what about charging, or what about X, Y, or Z. So, it was interesting to me. It was kind of a lesson of really how powerful momentum and even maybe denial could be, for whole industries that had so much, going in their direction.
And what I remember is like, yeah, but you can't scale. It's one thing to make, 50,000 cars a year, which, not that long ago was what Tesla was making, but making 500,000, that's a whole different game. We've been doing this for 100 years. We know how to scale manufacturing. And Tesla had some challenges.
Yeah, they were almost right.
Yeah, right? There's a couple of near-death experiences there.
Well, truly, scale is enormously difficult. And, that is another, I think, underappreciated challenge. If I kind of zoom out on the history of Tesla, getting the technology right was a relatively small percent of the problem. It took a small team and a small amount of resources, and then getting scale correct and doing that profitably was enormously difficult. It took 1,000 times more resources and people.
And did you think that the GMs and Toyotas of the world would respond faster, would change faster to what you were doing?
Oh, absolutely. We were almost maybe idealistic internally, and we kind of thought, oh, okay, we've really shown them now, and this car will, move the whole industry, and look at this, and then it would be kind of frustrating when we'd see the reality that no one would change, and everything would kind of continue on the same way, more or less. And it's only been quite recently when, I think due to, really customer pressure and economic pressure that a lot of the OEMs have truly and genuinely started shifting and changing.
So what changed? Did they get scared? I mean, you're clearly taking away market share from BMW, Mercedes, these premium luxury brands, and now you're moving into the Model Y is almost the most best-selling car in a lot of places. It's the new Toyota Camry, the utilitarian, affordable vehicle for the masses.
Yeah, it's an incredible vehicle, and as you said, best-selling in many different countries and regions. So I think it's the data on what customers are choosing and the staying power of that, the fact that that's lasting year on year and growing, and not some fad. It's lasting through high prices of oil and low prices of oil. Mm-hmm. That's I think what's finally shifting is really the customer voice and the customers demanding this of other brands that they maybe are loyal to.
Right, and Bloomberg has written about the tipping point. Now we're seeing, 20% or so of new car sales in California approaching, and companies saying they're going to stop selling gasoline cars, pretty soon, 2035. There's no way that doesn't happen. That happens without, Tesla. And as a CTO for 15 years, you were instrumental in everything from the Roadster 6,830 batteries to other things. I think this has achieved the speed and scale that is often talked about by investor John Doerr and others that to address the climate emergency, we need things at speed and scale, and few companies and honestly few individuals have achieved speed and scale like you and Tesla. So what lessons do you learn from that?
Well, it was definitely difficult. That was more difficult to do both those things than we would have assumed in the beginning. But to make an impact on sustainability, on global climate, you need scale. Ideas and startup ideas are relatively more common, but we need things that can scale and do it enormously quickly to actually make a dent on the whole problem.
The brand has also been damaged by the politics, the offensive comments of Elon Musk recently. Why did you step down from your position in 2019, and then you recently came back on the board?
Well, I mean, I love Tesla. I always have. I feel like, it has some sort of place in my heart, and it probably will for the rest of my life. I love the team there. I love the mission, the products. It's awesome. Doesn't mean it's an easy place to work. It's challenging. It kind of needs to be successful, I think. Part of why, I decided to leave back in 2019, and it was incredibly difficult personal decision, probably the most difficult decision business-wise in my life, was really reflecting on what I enjoy and what I'm good at. I love being an entrepreneur, and I love creating and building and being an engineer, actually being hands-on and really tinkering and building things. Certainly that was still possible to some degree at Tesla, but more and more the company needed execution at scale. It needed vehicle deliveries, it needed sales, it needed manufacturing ramp, and there were people that are more passionate about that, and frankly much better at it than me. And that's kind of a difficult thing to admit sometimes when you're in the midst of it, and especially if you've kind of like grown in an organization to have a position where maybe you're managing these people or alongside them, yet you kind of have to realize that, wow, these people they're really passionate about doing the thing that I have to kind of force myself to do because I know it's important. So for me, that was all part of that calculus. And I also, from a topic point of view, really, I love learning, and I wanted to kind of go into an adjacent, supportive, I thought, field, where I could do something that would potentially kind of float all the ships and help electrification, help sustainability, more broadly, using kind of what I'd seen and what I learned in our struggles and some of our challenges at Tesla.
Redwood is positioning itself as a battery component manufacturer, though it's grabbed a lot of headlines on recycling. And so I want to start there about, according to one Stanford professor, 95% of lithium-ion batteries currently end up in landfill. Why is that, and how are you planning to change it?
Yeah, it's pretty amazing. And I think largely that happens because there's no obvious place of where people should take them. If you think about it, and you had a lithium-ion battery today, where would you take it? Most people don't know. So a lot of people, are storing them up. They maybe don't want to throw it in the garbage can. For those people that feel guilty, they'll put it in a box in their garage or in a drawer somewhere.
Have a box at home that goes back to the Trio. Yeah,
like the BlackBerry or something.
I don't know what to do with them because of the, yeah.
So that's that's an opportunity. All those batteries are their materials are still in there. They're still usable, as long as they get reprocessed and remanufactured.
A battery is more complicated than a beer bottle or paper or aluminum that we know about, and so there are more components, far more materials. But as new battery chemistries are developed, how big a challenge is it for you to separate all these different materials that are, because batteries are changing so quickly?
Well, that's part of, I think, kind of the technology fun of it all is, making sure our ways to recycle and separate all these things can adapt. But we also get this weird look in history of personal electronics, because what is largely being recycled is hopefully what's worn out. So we're getting things that are these, Trios and BlackBerries and flip phones and things like that occasionally. So we have to kind of be relevant and applicable to technologies that were quite old. We still see things like nickel-cadmium batteries coming in, and even lead-acid batteries from huge old devices. The reality of it is a lot more messy than taking a brand new clean feedstock and then doing something precise to it. I mean, I was used to working and building factories and building automation where we had the parts presented in pristine trays and everything was perfect, and even then, still, a robot would have an enormously hard time picking up the part that was in the perfect place, brand new, and putting it in the right place on the product and not somehow screwing it up. Here we have a barrel full of damaged, defective, dirty materials, and trying to automate that is a whole different type of challenge.
And Redwood Materials recently announced that after a year-long pilot program, it was able to recover important metals from used batteries at a rate of more than 95%. And just note that last I checked, gasoline is 0% recycled.
What's so interesting, I think, about battery recycling, and especially as it relates to EVs, is we can imagine this future where you don't need to continually, extract and supply some chemical into a whole fleet of cars. The batteries, today might be economically 95%, but technically they're 99 or more percent reusable. All the lithium, the nickel, the copper, and cobalt, all those critical metals. So what goes into that is quite complex. We have to invent ways to, neutralize the battery, to separate out electrolyte, which is somewhat hazardous, to make sure they don't catch fire at the wrong time in the process. And then purify and separate each one of these metals from each other. It is a lot harder than notionally taking an old beer can and melting it and then stamping it into a new beer can. You can kind of look at that and very clearly say, oh, it's aluminum, it's probably going to be aluminum in a new shape. But batteries are kind of a complex mixture of chemistry and chemicals altogether.
So this really is like a dream circular economy. So how does this work? 2011, I bought a Nissan Leaf, very early EV. It was range kind of around 100 miles. It went down 2016 or so. Time to I think I actually gave it away to a public radio station because I didn't know what to do with it. So what would happen to that Nissan Leaf or another used EV? But you take it back to a dealer. How does the battery get in your hands?
It has a lot of different pathways. We work with auto dismantlers. We work with sometimes consumers directly. If that's relevant, we work with service centers. Parts that might be associated with an OEM if it's a warranty battery.
A car maker. Mm-hmm.
Car maker. So it's quite complex, and it's kind of the Wild West right now because people haven't really evolved this at scale. We're even having to build and kind of invent efficient, low-cost packaging to be able to get like your old Nissan Leaf battery back from maybe an auto dismantler or a wrecking yard, mm-hmm. where the battery might turn up sort of dead or as scrap. We need to get it from there to a recycling facility. But I'm confident we will electrify everything. That's where we're headed. Every passenger vehicle, every truck, every boat, I think, trains, it's all going to electrify. It really has to. And once we're in that more steady state mode where everything's already been electrified, we don't need to keep mining those materials to make the modern version of the fleet.
But in the meantime, we're in this transition where there's not enough batteries coming into you. There's more EVs. Haven't been that many EVs sold. We still need raw materials to fill that gap between demand, right? And that means lithium, cobalt, nickel, copper, et cetera, they need to grow sevenfold by the next decade or so. And the social environmental impacts, child labor, all sorts of things. How can we get those materials in that transition responsibly?
Yeah, that's the complexity of this transition, is we have to do both things. We have to both support and realize that mining responsibly has to happen, or else we won't have a transition to recycle. But we also have to be planning ahead and really keeping an eye toward what does that future look like to be ready to recycle every one of those batteries. Because the worst thing we could do is mine it, go to all this destruction and trouble to mine it, refine it, build the product, and then throw it away. That's the worst pathway.
So Redwood Materials, your company, is investing $3.5 billion in a gigantic new South Carolina manufacturing facility that will produce enough battery components to power 1 million electric cars. What percentage of the raw materials for those 1 million batteries will actually come from recycled batteries, and in what time frame?
Well, we're also building a large campus in northern Nevada. So we have sort of two main facilities, northern Nevada and South Carolina. And as part of the materials we make for batteries, the cathode material or the foils that make up the anode, we'll target between 30 and 50% recycled material. So we blend some mined material along with the material we recycle and refine to go into a new battery. Now, there's no reason it has to be blended like that, but that's basically the sort of balance that we see is about the maximum rate that we can ramp up the feedstock of recycled material.
So sounds like you're a technologist. You believe in technology, but there's also, the other side of JB, the human personal side. How do you feel about the broader transition we're making? Are we going fast enough?
Well, as you said, I'm an optimist on the capabilities of what technology can do. I can see a pathway. It's kind of frustrating to both see a pathway that can solve things with known technology. We don't have to invent new physics or chemistry.
We just use what we have today.
We can do it today. But at the same time, we are not going fast enough. We're absolutely not going fast enough. And I don't think we maybe collectively realize how bad it probably will get. There's so much inertia in this system that we're meddling with.
Or how bad it is. 100 million Americans were under heat watches this week.
Yeah, so it's it's part of what lights the urgency, for me, is seeing and feeling the fact that this problem is so big. It touches every part of our economy. Really, it's not a dramatization to say that. I think it's something we'll be grappling with and changing and working to solve for decades. Our kids and our kids are going to be working to solve and transition around this problem.
Well, certainly there's a handful of people on this planet who've done a lot, and certainly Tesla has disrupted and changed the whole industry. Not perfect, created a lot of wealth, but certainly Detroit and Tokyo are moving a lot faster thanks to you and your work. But one of the reasons it is going slow is that there is real organized, well-funded opposition. The International Energy Agency, the world's foremost authority on all things energy, recently issued a milestone forecast saying it predicts global demand for oil to be burned will peak in just 5 years. So oil companies are facing shrinking demand. You and I watched a recent advertisement by an oil company that it associates plug-in cars with chains, basically enslaved, and that driving a fossil car is liberty and freeing. And this was by a mobile ad that is out there, which is part of a campaign that really is going more directly at the companies that you're part of, Tesla and Redwood, saying, basically, you're enslaving us.
I almost take that as a little bit of respect. It's like, okay, we've finally gotten to them a little bit. But, unfortunately, it's going to take so long for us to reduce the entire, because really the amount of oil consumption scales with the fleet of cars, not with the new cars sold. And a lot of times we track our progress on EVs against new cars sold, and we're celebrating 20%, which is huge. It's a great milestone.
Right.
But that's 20% of the new cars going into a pool that takes perhaps 15 years to turn over. So, that's the sort of math around that, has a much bigger inertia to it. But anyway, I can't imagine what's more free, though, than driving an EV powered on solar energy at your own house. To me, that's the most free, set of products and technology you can possibly have. A cord is linking to your own roof. It's not linking to the Middle East or to to even a different part of the U.S.
UAW negotiations are heating up around job transitions to the EVs, the so-called battery belt, the region with new battery and EV factories in the southeast, right-to-work states are not welcoming to unions. Tesla has been hostile to unions. Where do you and Redwood Materials stand on worker unions?
I think it's important to figure out how we fairly transition. Essentially, if you look at this whole movement that has to happen, we have to transition a whole bunch of people working on various fossil fuel products and technologies and minerals, and somehow move all of them, if they're not retiring, move them into, sustainable industries and sustainable products. So, broadly, to me, that's sort of probably the most, key metric of success is where and when we can do something like that. Again, it's hard to do because their jobs aren't in the same regions, or maybe the skill sets are different.
Very different, yeah.
But that I think is what has to happen for success here. We can't just sort of, say, okay, those jobs all go away and those people won't do anything. But the other problem is we need huge amounts of jobs to do these new things. So we end up spending a lot of time training and recruiting and hiring, and it's a blend of almost vocational training, starting even in trade schools and community colleges and universities, because we, as a country, we don't have enough of the right skills to do some of these things. I would sort of implore students out there right now to really start try and learn a little bit more about chemistry, electrical engineering, some of these sort of different disciplines that aren't quite maybe weren't as in vogue, weren't as trendy over the last few years.
You said that you don't think anyone's moving fast enough. How can we move faster?
So much of this is driven by consumer choice. it feels both simple and hard, but I really do think that things could move faster if people understood a little bit better how to make truly sustainable choices. And if there were even, that leads to more products, it leads to driving behavior of other large companies. So I think, we need more investment, as I said before, in all these different areas, but I'm not sure I have a magic bullet for how to suddenly get more investment. I can see that it's needed, but that itself is a slow process.
Yeah, we're all clinging to the things that we know and kind of the things that got us to where we are. How optimistic are you that technology can make the change, and what other kind of changes do you think we need?
Well, I'm incredibly optimistic about what the technology can do. I'm pessimistic about the speed. So
are you pessimistic about the human part of it?
Well, it's a good question. I think, yeah, maybe I guess that is one of the complexities. It's the human preferences and choices, and all the complexity of changing behavior, and as we talked about earlier, this transition will move a lot of wealth from one company to another. It moves jobs from one region to another. It has political impacts. It has government impacts. So anytime that there's some technical shift that affects people in such personal, visceral ways, it's a very complex thing to affect.
Yeah.
So I guess I am a little bit concerned about how fast all those human complexities can sort of work themselves through.
Mm-hmm. Yeah, there's lots of systems we need to change. The economy, water, food, the system between our ears is one of the most challenging systems to address. We have to wrap it up. Thank you, JB, for joining us on Climate One and sharing your insight and stories, and really one of the true climate heroes for your passion for all that you've disrupted and done. Thank you, everyone. Thanks, JB.